This is going to be episode 2 in our rectangular and polar coordinate series. So in episode 1, we talked a little bit about rectangular coordinates, and this is typically what you will see it graphed on, and they are written in the terms x and then y. We talked about polar coordinates, and those are written in the terms of r and then theta. We actually graphed a coordinate using polar coordinates. And then we talked about if you want to go from rectangular, so this is what we say rectangular, to polar, use this here. This here says that r squared is equivalent to x squared plus y squared, and theta is equivalent to the inverse tangent of y over x. And all of that makes sense when you have a triangle drawn on here. And you know that theta is coming out of the origin. This is going to be our y, this is going to be our x, and this is our r. And we know without a doubt, using the Pythagorean theorem, which we absolutely love, that x squared plus y squared equals r squared. And that is where that formula comes from. It's just the Pythagorean theorem. Now, the way that we found tangent was because if we're given y and x, then we know that the tangent of theta is opposite, which is y, divided by adjacent, which is x. And then, of course, if we want to get theta alone, we do the inverse tangent on both sides. And so that is where the second piece of this comes from. And that's how we can switch from rectangular to polar. So let's go ahead and do a couple of examples where we want to switch from rectangular to polar coordinates. So let's say this is going to be example 1, and we want to change this to a polar coordinate, and let's say we have one, I don't know, let's do 1, 5. So this one isn't going to be super pretty because that is not a Pythagorean triple, but we can still use all of this same information. And so the first thing that we want to do is we want to figure out what is r. So r squared equals 1 squared plus 5 squared. So r squared equals 1 plus 25. So r squared is 26. Now, we want r, so we'll take the square root of that. And like I said, this one won't be pretty, so this is just going to be the square root of 26. Generally, when you're taking the square root, you're going to get both the plus and the minus. Well, we're only going to work with the principal square root meaning the positive one, because r is always positive. So when we start writing this in a polar coordinate, the first thing that we're going to get is the square root of 26. Now we need to figure out theta. And so theta is going to be the inverse tangent of y divided by x. I need to plug that into a calculator. I don't know how to do that off the top of my head, so I'm going to click on Desmos. And if you click functions, there is inverse tangent. And 5 divided by 1 is just 5. And then I want to make sure that I am in degree mode because right now we're putting things in degrees. If we were putting it in radians, which we can do that, then you would just click radian. So in degree mode, the inverse tangent of 5 is going to be 78.7 degrees. So let's go ahead and write that out. This is 78.7 degrees, and that is the second part of this ordered pair. Now we could certainly graph that on our polar coordinate system here. Well, the square root of 26 is a little bit more than 5, so we're going to want to go out to at least 5 radii. 1, 2, 3, 4, 5. So it's going to be a little bit further than this point here. And then we need to go 78 degrees. So this is 45 degrees right here. This one right here, I believe, is 60 degrees. And so it's probably going to be somewhere around here. That would be our ordered pair square root of 26 and 78.7 degrees. Now, of course, we could do this in radians as well. We could figure this out in something in radians. Let's try to find a pretty one here. So let's say that we have the rectangular coordinate 8, 8. And we want to put that into a polar coordinate. Well, to get r, we are going to have to do r squared equals 8 squared plus 8 squared. R squared is going to be 2 times 64. So if we were to take the square root of that, we're going to get r equals 8 root 2. R equals 8 root 2. Okay, so r equals 8 root 2. And remember, we're doing this one in radians. So we're doing this one in radians. We found our r. And now we want to find what is theta. And so we have to do the tangent. We have to do the inverse tangent of 8 over 8. Well, 8 over 8 is 1. And the inverse tangent of 1 is pi over 4. And so that is going to be our angle in radians. So we have 8 root 2, and then we have pi over 4. Okay, so I want to give you guys a couple as kind of your action points. I want you to try these ones out. And if you have questions about them, you can either drop them in the comments below or you can wait until our live session and ask there. And so the first one I want you to practice, I want you to go in degrees. In degrees, I want you to go from rectangular to polar. And you're going to start with, let's say -3, 6. Okay, so in degrees, I want you to go from rectangular to polar. And then for question 2, I want you to do this one in radians. And again, you're going to go rectangular to polar. And let's say you're going to have 3 root 3, 3. Let's say that's going to be your rectangular. So, yeah, go ahead and work those problems out. If you have questions, drop them in the comments below or wait until our live session.